Okay, so this will be the conclusion of 6.3, the division. Okay, I want to do one last one, like the long division way. Okay, and then kind of show you there is another option out there that works sometimes. Okay, so take a second. Let's see if we can get this one going. Actually, let's do it together because there's a little difference in this one. Okay, so this is one more long division problem, but again, this one's a touch different than the ones we've done before. Okay, and the reason is, and what I want you guys to start thinking about, okay, because with the new method, we got to think like this. Okay, start thinking kind of like having place values. Okay, and what I mean by that is like when you look in this numerator here, the important things on polynomials are like the exponents. Okay, so this thing's, it's going from an x to the third, then it has something x to the second, then there's something x to the first, right, and then there's just a constant with no variable here. Okay, so that's what we want. We need to have like every exponent needs to be, represented. In the denominator here, it goes right from x squared, there's no just x term. Okay, like a b value kind of, this one doesn't have it. Okay, so we need to put that in. So I need you guys to think of this, or anytime this comes up, as having 0x terms. Okay, we can't just jump from x squared down to a variable without having the regular x in the middle. Okay, it's kind of like place value. Okay, so when we do our division, it's going to make things line up a lot nicer to do it this way. So that's the thing that's going to go on the outside of my long division. Okay, and again, the numerator was good. It had all the exponents. It went from a third to a second power to a first to a constant. Okay, and again, this is just going to make everything line up a little bit nicer. Like we're not skipping any pieces. Okay, and with the new method, it's a must to put zeros in when there's not a term there. Okay, so let's do our long division like usual then. Okay, it's still the same process. We're going to just look at the first term, x squared going into the first term here. Okay, so nothing's changed now. X squared into x to the third is, it goes in x times. Okay, and then we still multiply the x times everything, and then subtract. So x cubed, okay, I'm distributing x to all of this now, right? So x cubed, I would write this next term, even though it's times 0, again, just to line it up, it's really like having 0x squareds. Okay, so see when we do our subtraction, it's going to be like, you can kind of visualize what you're subtracting. And then plus the 1 times x is just x. Okay, so we have 3 terms in here now, but we still subtract, and we'll still bring down the next term. It's just that we have 3 terms there. Okay, so let's subtract the whole quantity. Okay. Okay. Okay, so now we're going to do our subtraction. Okay, so just like before, right, x cubed minus x cubed is nothing. Okay, the negative 3x squared, if we take away 0x squared, it's still what it was before. Okay, the x minus x is 0. And then we always bring down the next term. The term that we didn't use yet is the minus 3. Okay. And now we're going to continue the process one more time. I'm going to see how many times does the x squared go into the first term here. So negative 3 times, right? So x squared times minus 3. All right, and then we'll multiply the negative 3 times everything out there. Okay, so negative 3x squared. Okay, we have a plus 0x. This one, it doesn't matter if you write it or not, because see in the green thing here, there's nothing to combine it with anyways. So just to be on the safe side, let's just write it. And then it's a minus 3. Okay, and now we're going to do our subtraction again one last time. So 3x squared minus negative 3x squared, 0. But negative 3 minus negative 3, 0 again. So we get no remainder. So this problem is done. Our answer is just x minus 3. Okay. It's just like a place value thing, yep. Exactly. So it's kind of like thinking about, if you had a problem, like like if you were dividing something by 103, you have to have that zero there. Like you have a ones digit, a tens digit, and a hundreds digit. That's not the same as just writing like 13, is it? No. So this zero again was just kind of a placeholder because the original divisor did not have all the terms. It had a squared term, but it didn't have an x term, and it went right down to the constant term. Okay, so that's going to kind of come up as we do some of these new ones too. Okay, so any other questions on that one? Yes. When you're doing long division, I think it could still work. It's just going to get a little confusing, like when you're getting in here to like do subtractions and stuff. But with this new method, we're going to do something today, synthetic division, you must put the zeros in to make it work. So get in the habit of doing it. Okay. Okay. So anything else on that one? Okay. All right. So then the last part of this section then is again, it's a little bit of a new method. It's like an alternative to long division. I think you guys will like it. It's a little bit easier. Okay. It's called synthetic division. Okay. So it's a method that can be used to divide polynomials. Okay, by a linear binomial. So we'll talk about what those look like. Okay, with the coefficient of 1. Okay, so again, this is a method that can be used to divide polynomials, but it has to be a special type. You have to be dividing by something that's linear. Okay, so like the one we just did, when it was x squared in the bottom there, right? This thing is not linear. Okay, this x squared plus 1. Synthetic, the new method wouldn't work. You're going to have to use long division on problems like that. Okay, because how can we tell if something is linear? What does it, is it going to have like an x squared in it? Can it have x to the third in it? No, okay, no exponents basically. So the thing you're dividing by can't have any exponents on a variable. Right, no square roots under or a variable under a square root. Um, yeah, that's for like polynomials, I think you guys think. But remember, linears are going to look like mx plus b form. Okay. Right, yep, that'll be true also. So we need something linear, so something with no exponents on it. So it's going to look like, you could divide by something like, actually, let's go to the next page and I have some specifics. But this second part, the coefficient of 1, we'll talk about that too, okay, right now. There are ways around that, but it must be linear. Okay, and binomial means it has two terms, right? Okay. So some of the ones that you divide by 3 terms and stuff, this new method won't work either. Okay, so 2 terms, linear, no exponents. Okay, so this next page you might just want to look and just think instead of writing it all down. If you want to write them, that's fine. But here's like 3 sample division problems. Okay, and just to kind of get us used to looking at these, think about which one or ones of those meet the conditions of being divided by a binomial that's linear with the coefficient of 1. Okay, definitely A looks good, doesn't it? Okay, so A is like the perfect situation for synthetic division. This is great. We're dividing by a binomial. It's linear because there's no exponents. The coefficient's 1 on the x, right? So this is perfect for synthetic. This is what we want. Okay, that's best case scenario. What about B? No, B you can't use it. Okay, this is a quadratic that we're dividing by. Cannot use synthetic on that. So if you see that problem, you have to use long division. Okay, so that's why we did long division first. Okay, it's always available to you. Most of the problems we're going to do though from now on, you will be able to use synthetic division, but there'll always be that occasional one that's thrown in where you have to still use long division. So what about C? Okay, it's linear, right? Right, so there's a problem with the 2. Now there are ways around it. Okay, if we were going to use synthetic, you would have to divide every term by 2. Okay, so if you wanted to, it can be done, and I'll show you one, we'll do one, but you would have to divide all the terms by 2 to make that 2 become a 1. And sometimes that's going to cause you to get a bunch of fractions in your problem and stuff. But it's doable, and if you hate long division and you see a problem like this, I'll show you you can do it the new way. But if you don't mind long division, you might want to just do it that way. Okay, because again, it's going to get some fractions. If you think about it, if you divide all these things by 2, right, that's a half, 7 halves, a half, a half, 3 halves. So it's doable. We're going to be doing some calculations with these numbers in a few minutes. Okay, but it's a possible. Okay. Oh, sorry. Thanks. So they're all divided by 2. Okay. Yes. Yep. A 1 coefficient, no exponent. Yep. Okay. All right, but B is out of the question. Okay, we're not going to do B with the new method. A and C can be done. A is perfect, C a little bit of work. All right, so let's do one. Here's the process. Okay. Okay, so synthetic division. So looking at that problem, that's like one you guys would have done on the worksheet you just turned in using long division, right? That's just a division problem, right? Okay, so long division, we kind of know how to do that. But this is perfect for the new method because again, the thing we are dividing by is linear and it has no exponents and the coefficient's 1. Okay, so this method, like the word synthetic, it kind of means like it's like a made up method. So we're gonna do this problem and it's not gonna even feel like we're doing a division problem, but it's gonna work and it's gonna give us the answer. Okay, and it's gonna seem kind of weird and random at first, so just bear with me on the first one or two. Okay, and then you'll get the process down. Okay, so here's what we do. Again, it's kind of a weird process. You look at the thing you're dividing by, r minus 2, and we take the opposite of the number there. So instead of like a minus 2, I'm going to take a positive 2. Okay, and we're going to do some calculations with that, but I want to put that like a little half box around that to know that it's like separate from the rest of my problem. Okay, we kind of take the opposite, throw that in a little half box. Okay, now what we're going to do is look at the coefficients of the numerator. Okay, so my numerator up top has a bunch of coefficients on there. And what we're going to do is write those coefficients in order in a line across the top here. Okay, and what we want to do to make sure is we don't skip over any exponents. So like we started with something to the third power, the next term was to the second, the next was to the first. So we don't need any zeros or anything in here. We got everything in. And you're going to write those coefficients in order right next to here. So I have a positive 5, I have a negative 13, so I'm not writing the variable or the exponent, just the coefficients. 10, negative 8. Okay, and this is kind of why this method is going to be a little easier. We don't have to worry about the variables and the exponents, and you're just kind of dealing with numbers when you use this method. That's why a lot of people like it better. And it works. Okay, and here's our step, our process. Leave a line to do some work and put like another line down here, but leave space. We're going to put more numbers in the middle. Yep, it's a positive 10 sitting there. No, nope, these are like 4 separate things. Right. All right, now here's where the magic starts. Ready? Here's your process. Bring the first number down. Not the 2 that you have in the box, but the first actual coefficient just gets brought down. Okay, so we got 5 down there. And the process from here is you take the 5 and you multiply it by the 2, whatever's in the box. 5 times 2, that's your next number. Okay. Now we're going to add straight down. Negative 13 plus 10. Right, okay, so we're adding here. Negative 3. And we just continue that process. Now the negative 3 gets multiplied by the 2. Okay. Add again. 10 and negative 6 is 4. One more time. 4 times 2. Add to get 0. Okay, so we got a bunch of random numbers all over the place, right? Okay, it actually means something. The last number, sometimes we separate it off, that is your remainder. If you were to do this division problem, the remainder would be 0. Okay. Yeah, pretty much. We just need to put our variables back in. Those are the coefficients of the answer. Okay, so what we do is, and here's the one thing you got to remember. Again, we started out third degree, right? Okay, we divided by something to the first power, first degree. What that does is make this third degree decrease by 1 to become a second degree. Okay, our answer is going to be a second degree. Our answer is 5r squared minus 3r to the first, and then a positive 4. Those coefficients in the bottom row of our chart are the coefficients to the answer. Okay? Yep, like because that comes from here, right? Yep. Okay. Okay. Question. Yep. Not if there was like an exponent on this r. You couldn't use this method. It only works for dividing linears out. Okay. Mhm. Yep. Um, if there's a plus 5 here or here. Oh, if there was another spot here, then that would force this to have been one higher to start with, and it would just like kind of fill in and work. It just kind of works. Okay, we'll do one. Let's do one. Let's do one more. Okay. All right. So 3c to the fifth. Okay, plus 5c to the fourth, plus c plus 5. Okay, and we want to divide it by c plus 2. So is this ideal for synthetic? Yeah, that c plus 2 is exactly what we want down there. Okay, it's linear. I don't have to divide anything out. It's already a 1 coefficient. Okay, so I'll kind of start it, and then you guys can get going, because there's one little thing to watch for on this one. So what goes in the box? Negative 2. Okay, it's always the opposite. All right, now be careful when you get your coefficients from the numerator. Did we skip a few exponents? Yeah. Okay, this is c to the first. We went from c to the fourth to c to the first. So for that c to the third, we need a 0. And for the c to the second, the ones that are missing in between these two. Okay, so I'm going to write a positive 3, c to the fifth, and just count down. Positive 5 for the c to the fourth. There are 0 c to the thirds. There are 0 c squareds. Okay, there is now 1 c to the first and a constant of 5. So those zeros must be there with this method. Okay? All right, so you guys get it going. If you want to peek up, feel free, but see if we got the process. Bring the 3 down and then multiply, right? Okay, so I did my little process, got all my numbers. This one has a remainder. Okay, that's okay though. What we just need to do is know how to write the final solution now. So we started fifth degree, right? And since we divided by a first degree, our answer is going to start fourth degree. And these are the coefficients in order. So it's a 3c to the fourth minus 1c to the third. So we just decrease the exponents as we go down. Plus 2c squared minus 4c. Then we got a plus 9. All right, and for that remainder, what does it always go over? The thing we divided by. Yep, so minus 13 over c plus 2. There's your answer. Okay, much faster than long division. And much easier. Okay, so pretty cool method. Again, it's synthetic. It's just kind of like made up. It doesn't feel like you're doing a division problem. Yep. It'll work with fractions, yeah. It just gets, like the calculations get a little messier because you're adding fractions and stuff, but it'll still do it, yeah. Yep. Okay, other questions on that one? You guys like this method better? Me too. Okay. But again, the drawback is sometimes you got to use the long division because it won't handle quadratics and stuff like that. All right, so there's one more I wanted to set up with you guys. This is the case where the coefficient's not 1. Okay. Okay, so as you're thinking about this one, you got to kind of weigh your options and decide, do you want to just do long division because of that 3 down there? Or do you feel like doing a bunch of work with a bunch of little fractions and stuff? Because remember, to make this to work, we got to divide everything by 3. Okay. Okay, because this is not a 1, right? So we can make it a 1 as long as we divide every single term by 3. Yeah, so if we do that, if we divide everything by 3, you get a whole bunch of fractions. Here's a 1/3. Divide that by 3. But honestly, you'll see it doesn't work out as bad as you might expect, but it can. Sometimes the fractions get really messy. But this one's really not as bad, okay? And we'll do it. I just want to show you guys it can be done. Okay, so I divided everything by 3 to make my coefficient 1. And then we do the same deal. We're going to kind of take the opposite of what we see in the denominator. So I'm going to put a negative 1/3 in the box. All right, now some of the coefficients aren't bad. 6 over 3, that's really a whole number. That's really a 2. The next coefficient is 5 over 3. Then 1/3. Okay, then we have negative 3 over 3. That's just negative 1. And then 1/3. Okay, so it's not the end of the world. If you hate long division, you might want to go this route. But if you hate fractions, you might want to go long division route. So pick your poison, right? All right, and then let's do the process. This one, I'm telling you, it's not going to be as bad. So you bring the 2 down, right? And then the process says multiply that by the thing in the box. So 2 times negative 1/3, negative 2/3. All right, and when we do the addition, 5/3 and a minus 2/3, how many thirds? 3/3, which is just, boom, 1. Positive, right, because it's 5/3 minus 2/3. And then we multiply the 1 by the negative 1/3. So negative 1/3, add those two. Okay. 0, right? Then 0 times anything is 0. Negative 1 and 0 is negative 1. And then the negative 1 times the negative 1/3 is positive 1/3. So 1/3 plus 1/3 is 2/3. So this thing has a fractional remainder. Let me get this out of here. This is supposed to be erased. Okay, so we got, most of them were nice whole numbers. It wasn't too bad, but the remainder we'll have to deal with. So let's get the answer written. What do we start with? A degree of fourth. Okay, so our answer is going to be starting to the third, right? So 2x to the third plus we got 1x squared. I'm just going to write the 0x, even though we usually wouldn't write it if it's a 0. Then minus 1. But then our remainder is a fraction, and it gets divided by the thing we divided by, which was x plus 1/3. Yeah, because that was the original thing, right, up here. No, because remember, we really divided them all by 3, right? So the only problem is this, this doesn't look too good, does it? It looks kind of complicated, okay? And it's called a complex fraction. If you have like a fraction inside of a fraction, not good, okay? Is there something we could multiply top and bottom by, though, to make that not be a fraction? Yeah. So sometimes you just need to clean that up. Like if I were to multiply this by 3, as long as we do the whole bottom by 3, we can clear those fractions out. So this is where using this method is a little messier. So we got 2x cubed plus x squared minus 1. And then if we multiply that fraction top and bottom by 3, what do we get? This is a 2 over 3x plus 1. Got to distribute the 3 to both. So that would be like the final answer without complex fractions in it. Okay. Okay, so you choose. You want long division or you want that. Okay. But again, keep in mind sometimes the intermediate steps get worse on these with the fractions. So I would probably lean to long division, but it's your call. Okay. Okay. So that is that. So the assignment tonight is in the book. You guys have some time to get started. Some of it's older where you just split it up and reduce each piece. And then some of them you're going to have options between synthetic or long division. So give that a look. Make sure you're showing me steps. Okay, so I can give you full credit. Okay.